Hi guys, and in today's video I'm going to talk to you about the IB physics, which in the topic dynamics. So um, before we get started, I actually post some SAT math solutions in this channel, but today we're going to do something different, which is IB physics. So let's get straight to it. So firstly, the foundation of dynamics is the actually the Newton's laws, and which we use in our daily life actually. So these are if not the most crucial law in our daily life. So in there's three main laws of Newton's in dynamics, which and the first Newton's law is inertia. Inertia means that if an object is stable, it will show an endurance to not get unstable. That it is actually directly proportional with mass. So we can see that. Let's take a daily example, which is like, let's think about we're in a moving car, right? So, if the car, if the if the car gets an acceleration, we're going to move to backwards, right? Everybody knows that effect. Cause like, if there is a hard acceleration in the car, we're just going to go backwards and get tighter for sit tighter. So that means that your body is actually um, trying to stay at its former situation, but with the acceleration, you're just going to your body is going to how can I say, like, your body shows an endurance to it, so you just don't want to do it, but you just want to stay at the position that you were at. But the it's just like the first law just states that, and you can see in this example the v is not constant, which means that the car has a acceleration. But if the car is constant, just going to the object is going to have the um it's going to stay stable. It's going to be stable, so it won't move to a different position. So that's just it. The second law of Newton's, which is F net equals ma, which is the, if not the most how can I say, like, known law of Newton's. So second law of Newton states that the of net force applied to an object is equal to mass times its acceleration. So as I wrote down here, it's just pretty simple. Um, as we can see from inertia, we we actually I actually told you that the if the car has an acceleration, we're just going to feel that force applied, right? So it's just that. So there's an example of an object which is showing what's the acceleration of the object. So the second law of Newton states us that F net equals m times a, right? So there's a 60 newtons to the right, 60 newtons in plus direction, and there's F friction, and that's 10 newtons in minus direction. So we're just going to take the net force, which is 50 newtons to the right, plus 50, right? Which means that it is just going to have a 15 newtons net force of 50 newtons to the right side. So we know that if F, I'm just going to write in different color. If F equals ma, if not equals ma, it's going to mean that 50 equals 5 times a, which is going to tell us that the acceleration is 10 meters squared. 10 meters divided by second squared. So we're just going to solve different and better questions about it, but I'm just want you to have the basic idea of what Newton's laws are, for the first example at least. So, the third and final law of dynamics is action-reaction force. Third law of Newton states that if there is a force applied, there must be an equally opposite force to it. This is the law we use to make planes fly and take rockets to the outer Earth orbit. Actually, this is the as I said, make planes fly. Because if you may know that from the planes, these planes just take the air and so make it faster and go. How can I say, like, it just planes more just like engine takes the air and just push itself, and so that's it. This is action reaction, as well as the rockets as well. So I wrote down here. So if you take gravitational acceleration as 10, there's a 50 newtons to from object's weight to the ground, from object to the ground, and ground is going to apply a opposite action reaction force, is going to be normal force, 50 newtons of normal force as well. So you can just like think like that. And the universe is just neutral, right? It's just so if the universe is neutral, there must be something opposite to an thing. So to maintain its neutrality. So the example that I want to solve and end this video with is this example right here. So just can try and do by yourself. I'm just gonna wait a couple seconds. So let's get straight to it. And I wrote the surface is frictionless, so F net is going to be 60. So we know from that F net equals m times a, right? So 60 newtons equals 3 plus 2 times a. Why 3 plus 2? Because this force actually pulls 3 and 2 together. We just think it if like it's they're connected to each other, and just we can, and that way we can solve the question. So 60 newtons, 5 times a, which is going to be, a is going to be 12 meters squared. So we just found that a is 12. From now on, we can just solve T1. We actually know from that F net, which is T1 equals m times a, is going to be T1 equals 2 kgs times 12 meters per. We can find that it is going to be 24 kg m squared, which is 24 newtons.